So this video is going to be a continuation of sustainable energy and renewable energy. So first we'll look at using biomass for energy. Biomass, you can see here, we're looking at animal waste, forestry residues, agriculture residues, municipal waste even. So what we could do is we can burn that as a form of energy. So we can burn it to produce heat, or we can burn it to produce electricity. Ways in which we do that, mostly with like agricultural residue, we put that into what we call a digester. That digester then breaks it down. It allows bacteria and even yeast cells and stuff like that to work on it, and that produces a gas. That gas can then get burned to produce electricity. We then take that sludge and we can bury that, use that as fertilizer as long as it's clean, or get rid of it in an efficient manner rather than it. So one of the greatest upsides to using biomass, like we were saying before, you're using scraps that would wind up in a landfill, or like animal residue can go in and be digested and produce natural gas if it's not used as a fertilizer. Okay, some places with municipal waste, some places still burn their garbage or allow for the burning of garbage. So instead of doing that, this is a more efficient and sustainable, environmentally friendly way to do that. The downsides is that people will plant plantations just to be used for biomass energy, which is not really that sustainable, because you'd be either clearing forests or just setting up a land that's going to use a lot of the nutrients in the ground, and then it will go barren. So it's like we've talked in the past with constantly growing crops and not really returning any of those nutrients into the ground. It's going to fail at some point. If we look at liquid biofuels, it works the same exact way. We use some type of feedstock. Main one is corn. So corn would go to a refinery. That refinery would produce ethanol or alcohol that would go into a fuel source, and that fuel could then be used in machinery or cars. The upside to that is when you burn it, it's completely clean. We can just use corn or some type of plant material to produce this ethanol, so that's sustainable if done correctly. But our big downside is that it's using a food source. So a food source, as in corn, people consume corn, but also we feed it to animals, and that's going to raise the price of food sources as well. You can look at two examples that we've tried to use in the past, but the issue with that is that many places or government will not give subsidies to growing these because it's not a main energy form. So this is switchgrass here, and this is what we call elephant grass. They're very, very high in starch and cellulose to produce ethanol that way. It gets broken down. Those sugars are feasted on by yeast, and that yeast produces alcohol, and then alcohol can then be burned. Okay, so if we look at our trade-offs here, low net energy yield, that's not really that great. It competes for cropland. If done correctly, it can give us a high net energy yield, but it all depends on what's being used, and we can reduce those CO2 emissions, especially when it's being burned inside of cars. One of our other forms is called geothermal energy. This is where we're using the Earth's heat to then produce steam, and then that can produce electricity. So if we look here in the back, that's a geothermal plant. The geothermal plant takes the heat from the Earth's surface in the form of water. It's produced into steam, and then it actually has to release some of that hot water into these lagoons because the engines or the turbines that are spinning, they can't overheat. So some of the water has to cool those turbines, and they actually dump those into this huge lagoon called the Blue Lagoon, and it sets up this nice little area for people to kind of hang out for the day in like a spa-like, very warm bath atmosphere. We do produce a lot of geothermal electricity, and it is quite abundant. It's just a matter of where you are in the world. Certain areas are not able to tap into the geothermal due to how high up they are, or what their ground is really like, if it's too hard to really bore into the ground. So this is the way in which it works. We take that hot water or heated water from underground, we pressurize it right here, and then that produces that steam turbine generator and that produces electricity, and then we want to return that water back into the ground because we want to close that loop. We don't want to just keep drawing water out and not allowing it to return back down. We can also have geothermal systems in your house, and I'm just going to really talk about the summer one because that's the one that's more easy to understand compared to the winter. So in the summertime, let's say the outside air is about 80 degrees Fahrenheit, right? Underground, it's still going to maintain about 50 degrees Fahrenheit. So if the air is 80 degrees and you have a system in your house where air is passed over coils, and that coils, or inside of those coils you have water, if that water is about 80 degrees, it goes down into the ground, and as it hits this very, very cool earth, it's going to change from 80 to 50 degrees. That means when it enters back into your house, it's going to be at about around 50 degrees. You pass air over those coils, and that air coming off those coils is around 50 degrees. So that's your air conditioning right there. In the winter time, it does kind of the opposite, where it's going to take that cooler air, it's going to bring it underground, and that underground is supposed to be a little bit warmer than what the inside of the house would be exchanging. And there's a lot of stuff that happens with pressure with these basement pumps, but they are very, very efficient compared to a lot of systems that are in place nowadays. Okay, so you can see here we have moderate high net energy yield, or moderate high efficiency, low CO2, because it's not really producing that much other than the small amount of electricity for those heat pumps. But if we're looking at very, very large geothermal plants, they can be noisy. They don't really look that great in some areas, and they're very, very high cost upfront, for sure. Last one is hydrogen. Hydrogen cells, fuel cells. Fuel cells are coming around. Now, some people say they may never hit the market, but all we really need to do is capture hydrogen. Now, hydrogen is in water, H2O, and when we take that hydrogen and we pass it through what we call anodes and cathodes, we pass it through anodes, that's going to cause electricity to flow, and that's where you get your energy, and then our byproduct is really just water vapor. So the pro to it is that we have like a zero emission coming out. And there's a lot of hydrogen on Earth in different forms, but one of our biggest downsides is that it takes a lot of energy to get that hydrogen. So they're doing a lot of work on these technologies to try to figure out what's our best way to move forward with it. So we can produce it. There's no real CO2 that's released. The problem is the net energy yield right now is not really there because it takes so much energy to produce or to capture that hydrogen, really make that hydrogen. So that's a problem. And we need to switch our subsidies over to it, which we're trying to do that with electric cars, let alone trying to move that towards hydrogen cars as well. We would also have to set up a system where we have stations, just like we have gas stations, that would be able to store that hydrogen to those stations would be able to distribute the fuel to the cars when needed. Hope this helps, and we will be filling out our charts as a class for our next activity.